Hey everybody, welcome to another episode of a Random Linux Tool Explained or Random Linux Tools Explained. I'm Robert Wolfert, and if you're here for the first time, this is a video, a live stream about Linux command line tools. Linux command line tools you can use for your daily work at the Linux command line. And to make the talk about Linux command line tools a little bit more interesting, and there is a little challenge added, and the challenge is a challenge for me that I'm not prepared at all. Instead, I will get from a script a randomly chosen tool, and then I do my best to explain this tool to you, to explain what this tool can be used for, and how to use this tool at best, command line options, and so on. And if there are some things around this tool worth mentioning from my experience. So again, my name is Robert Wolfert, and let's start with choosing a tool, or better, let's start with sharing my screen and then let's choose a tool. Let's choose a tool. I have my repository here, the repository of tools, and the repository of tools here within the file tools.txt. These are, let's see how many tools are this. w/l tools.txt, 121 tools within this file. These tools are taken from the shell toolbox, and let's start a script. Choose tool.sh to choose the first tool for today. Okay, so mixing the tools, and the winner for now is PS. Okay. Let's talk about PS. If someone is later to the show, let's add a banner here. We are talking about the tool PS now. Okay, the tool PS. What's this? What can this tool be used for? This tool can be used for printing out running processes. And if you use the tool PS without any additional parameter here, then you will see all the processes currently running within your current terminal. We have multiple terminals available on a Linux system. Simply spoken, every time you log into a Linux system, a terminal will be opened. So I have here, for instance, two terminals. And if I start within one terminal, a tool, sleep123, for instance, and I have a look within a different terminal, what is the output of the PS command, I see I have only the bash running here, and I have the PS command running. On the other side, I don't have a prompt. Let's terminate sleep123. Let's restart sleep123 in the background. By the way, sleep is a tool that does nothing but sleeping for the number of seconds you give it. So I start sleep123 in the background now with the ampersand as the last sign, as the last character at the command line. And if I call within this terminal PS, then I see here runs the bash, here runs the sleep command, and here runs the PS command. So we see within a terminal, if you run PS without any additional command line switch, we see the processes running in the current terminal. The information you get here are the process ID. This is the only handle you have for every command. If you later on want to control a command, if you want to control a process, then the process ID is the only handle, the only really handle or real handle you have. Then we have the TTY. The TTY is the terminal where the process is running in. And we have here pseudo terminals available, PTS are pseudo terminals. I have here the terminal 0, the pseudo terminal 0. Here we have the pseudo terminal 1. Yeah, and then we have a time, a column time. This is the time, the CPU time this process has already used. Yeah, and the bash here, the shell here is running for quite some time, but the shell doesn't do anything but reading in a command line for me and then executing a command, and this only takes milliseconds. Yeah, and so therefore the shell, the bash here, doesn't have a single second accumulated CPU time for now. Yeah, so we have the bash, we have a sleep, we have the ps command itself. So this is ps without any additional parameter, without any additional command line switch. If you want to see all, okay, now the sleep command has terminated itself. We talked about, or for 123 seconds, yeah, about the ps command here. Okay, if we call the ps command, for instance, with the -x command line switch, or no, let's start with the a command line switch, then you see all your currently running processes. All processes running as you, running from your login shell. Yeah? So I'm here logged in as user Robert, and you see I have some processes here running started from my logon shell. You see here I've logged in via TTY1, for instance, or on TTY1 there is a command running. Oh no, I made a mistake. Yeah, perhaps, or because I just used the ps command together, or with these two command line switches together, A and an X. AX, the X stands for all your processes, and the A stands for all processes of every user on the system. So typically you don't want to see only your own processes. You typically want to see what's going on the system. Yeah, and for this you can use the PSAX command line switch. Yeah, PSAX shows you everything not related to a special terminal, not related to a special user, everything that's running on the system. And you see in the first column the process ID, and if I scroll up, yeah, I see the process IDs are just numbers. I think 16-bit numbers, and the first process started on the system is the process with the process ID 1. This is here on the system, the system D, the system daemon, yeah, which is the mother of all the other running processes. Yeah. And the second process that was started has the process ID 2, the next one the 3, and so on. So the next process that will be started on the system will get the next higher process ID until we reach the limit. I think it is the 16-bit limit here, 65,000 something is the biggest process ID that can be reached here. And then after we reach this highest number, then we will take, or the system will take, process IDs from the beginning. Yeah, so we see here we don't use the 4 anymore, so a few days, a few weeks later here could be a process with the process ID 4. Yeah, and here you see that there are some processes, for instance the process with the process ID 1, the system daemon here, running for quite some time, or they have used the CPU for quite some time, yeah, for 11 minutes 37 seconds. What's the uptime for the system? How long is the system up here? Let's have a look. the system is up now for 287 days. This demo system is really up this long, and within this 287 days, yeah, the first process on the system, head-n1, -n2 for instance, yeah, the first process on a system has occupied the CPU for 11 minutes 37 seconds. Yeah, so this demo system does nothing at all, yeah, all the time. Okay, so this is the output of psax. Sometimes, or let's have a look at the column here. We have a third column if we call psax. Yeah, we have the process ID, we have the terminal where this process is running in. Then we have the CPU time and the process or the command line itself. And then we have here a flag. Yeah, and I'm not extremely deep within process scheduling and so on. And I don't know every flag here, but I know the first flag within every line. I know the first flag from every line. And what is interesting is, or important here, is that SNS stands for sleeping. That means all the processes here with an S as the first flag, in uppercase S here, they are sleeping. They don't want to run. Yeah? And therefore they don't need CPU time. Yeah? And therefore they don't have occupied much CPU time yet. And if there is an R, an uppercase R, then this is a process that is run-able, that wants to run. Yeah. So if I have a look here, I think this ps command I have started, yeah, is the only command that wants to run currently. Yeah. All the other processes are sleeping here. Yeah. Okay. Great. psax. Sometimes it is interesting to see the user account this process is running as. Yeah? Every process that runs in the context of a user, and therefore it has the permissions this corresponding user has. So it is often interesting what's the user a process is running as. Let's say here is the process squid running, is a proxy server, an HTTPS proxy. And if this process needs read-write permissions somewhere, then it is important to know which is the user under or in which context the process is running. And for this, I just add typically a U to the command line switches, psaux. Yeah, the order here of the command line switches doesn't matter at all. Yeah, only we need an A and an X for seeing everything, and we need a U for seeing the user of the processes too. Yeah, and what you see here is we have added a first column, and the first column here shows that the squid process mentioned, that the squid process mentioned is running as the user root, but you see there is a child process, and I know this is a child process. We can have a look at these parent-child relationships in a few seconds. Yeah, this is a child process that does the real work, and this child process runs as the user proxy here. Yeah, so if this process, if the squid proxy server needs access to a file, to a directory, somewhat, doesn't matter, we need to take care that the user proxy has permissions to these files. Yeah. Okay. There is another interesting column added here if we call ps additionally with the U command line switch, and this column shows the start time of the process. Yeah, if we scroll up here, yeah, we see the start time or the start year or the start date of the process. Yeah, the system is up for 200 and I don't remember the exact time of days. Yeah, this was 2020 when the first process here was started. Yeah, then many more processes. These processes here within these type of brackets, yeah, these processes are typically kernel threads, so you don't have control about these processes, and these processes were started exactly at the time the system booted up. And let's scroll a little bit down here. Yeah, we see that the SSH daemon, for instance, was started on January 18, and then we have some processes that were started just today. Yeah, for instance, this SSH daemon here that I used for logged in from remote to the system, yeah, used or was started at 14:09. Yeah, okay. So if you use psaux, you see everything and everything running on a system with a lot of meta information added here. If you see over the shoulder of a Linux Unix veteran, you often will see that they use ps together with the command line switch -ef. Yeah. Do you see this? AUX without a leading dash, -ef with a leading dash. Yeah. The PS tool is a GNU tool, and GNU tools were implemented in the early Unix days, and there are multiple different Unix systems state of the art at the time, and the PS tool was created. So there was a PS tool on one Unix system available and a PS tool on a different Unix system available, and they behave differently. And the GNU PS tool, the PS tool we have here, implement both behaviors. Yeah, so you have command line switches without a dash, you have command line switches with a dash, and these two command line combinations, psaux or ps-ef, they do nearly the same. Yeah, so let's call ps in this way, ps-ef, and you see again a process ID of a process, you see the user of a process, you see the start time, you see the CPU time occupied by the process for its runtime, and you see the process itself. Yeah, you see here the parent process ID. Let's scroll up a little bit. Yeah, we have a header of this table. Yeah, you see the process ID, and then you see the parent process ID, the process ID of the parent process. Yeah, this is interesting. Yeah, here you can really see which process depends from which process. Yeah, we have a parent-child relationship between processes. If you want to see this in a different way, just use the command pstree. Yeah, this is one single command, pstree, and this tool pstree builds up within terminal a tree of all your started commands. Yeah, I see at a glance that pstree here, this is the pstree I have started. Yeah, was started from a bash, this was started from a su, that was started from a sudo, was started from a bash, was started from an SSH daemon, and so on. And this SSH daemon then was started from, and now let's go up here a little bit, was started from the system daemon. So the system daemon here is the mother of all the other processes. So parent-child relationship means that if you have a parent process and this parent process terminates, or you kill it, or you terminate it, whatever, yeah, then all the child processes will be terminated too with this parent process. Yeah. Yes, we will see this, for instance, here. Let's say I start within this other terminal a bash. Let's simply start a bash, a shell, a new shell, and within this shell, let's start a sleep 5555, for instance. Yeah. Okay. Let's terminate it. Let's start in the background. Yeah. Sleep 5555. Let's go back here and let's have a look. psax shows you that we have a sleep 5555 here. Yeah. Okay. So now let's have a look with the pstree command, where in the tree the sleep command is, and here it is. Yeah. This pstree is in this bash, this sleep runs in a different bash, but it was started from a different bash, and so on. And now I want to stop, I want to terminate this bash. And then I want to see that this sleep command will be terminated too. Yeah. So let's have a look. Let's try this out. Let's try to leave the shell, exit. I have hit Control D. Yeah, it's the fastest way to leave a shell. Hit Control D, sends an end of file, and an end of file for the shell means on the input, okay, it's just, let's terminate. Yeah. So this shell was terminated. Let's see if sleep 5555 is still running. Yeah, psax. Wow, sleep 5555 is still running. pstree. Let's have a look. Where is the sleep process? And you see here the sleep process is now a child process of the process with the process ID 1 of the system daemon directly. Wow. Yeah. Here is within the shell a little bit voodoo built in. Yeah. My expectation was that a sleep process will be terminated too, together with the shell. Yeah, but the shell or the sleep process was connected to a different parent process. Typically, for this to work, you typically will use a command called no HUP, no hang up. Yeah. No hang up comes from an old way of working on Unix systems. You connect to a Unix system via a landline, via a telephone line, for instance, via a modem, and then you work there, and then your modem hangs up. Your modem hangs up. Yeah, you terminate your line to your remote system, and then all the processes on a remote system get a signal called hang up. Yeah, and these signal means for all these processes who get which get this signal, please terminate. And no hang up, yeah, just catches this signal and then reconnects the process that would be terminated otherwise to the process ID number 1 as its parent process. And if you want to be sure that a process runs after you left the system, start process with the no HUP command, no HUP 5556, for instance. No HUP sleep 5556, for instance, and then run this in the background. This is the best way. This is the way to be sure that the command sleep 5556 still runs after you left the system. Yeah? So if you call it in this way, then you will get an output no HUP ignoring input and appending output to to nohup.out. That means you have here now a file, a text file called nohup.out. If you come back later to the system, you can just have a look into this file cat, nohup.out, and you see instantly if this process has said something. Everything this process prints out will be appended to the file nohup.out. If you have a look into the help of the nohup command here, and then you will see that you can name the file differently. But by default the file is named nohup.out. And now if you leave the shell, then you can be sure that this sleep 5556, PSAX, this sleep 5556 is still running. So we have some voodoo. I would say some voodoo within this terminal that hangs or reconnects without calling nohup the processes to the process ID number 1. But if you rely on this, if you want to make sure that the process still runs after you left the system, then use nohup. And a really big advantage is that you have this file nohup.out. Let's imagine you copy a bunch of files, a huge directory tree over the network to a remote system, and that takes hours and hours or days and days. Then just start a copy process. For instance, nohup. Then let's say you want to use rsync for this. Cool. Copy your huge directory or your huge tree of files and directories to a remote system, remote : tmp, for instance, and rsync then prints out I have copied this single file and this single file, and we have 2 hours left to go or 2 days left to go, something. And then start the rsync in this way, in the background, together with the nohup command, and then log out from the system, come back later, an hour or 2, and then just have a look into this nohup.out file to see what the current state of the rsync tool here is. Okay, so pstree shows you all the parent-child relationship. What I use typically together with the pstree tool is the -i command line switch, the -p command line switch, sorry. The -p command line switch shows you or gives you the process IDs of everything. So there is no way for the pstree command to collapse parts of the tree. If you have the same processes running multiple times, or multiple instances of a process, then typically you see in the output of pstree something like this. We have 3 times these combinations, or we have 2 times a Redis server here. But if you call pstree with -p, you will see all the process IDs, and therefore nothing within the tree will be collapsed. Okay, this is the PS tool. Just use PS typically, or I use PS typically with AX. Sometimes I use PS if I wanna have a look into the permissions process needs. Then I call PS with the -u command line switch edit, or I call the PS command, or I see others calling the PS command with -ef. That gives you yeah, the same information, I would say, the same information like psaux. Yeah, a little bit other within the layout, yeah, but mainly the same information. Okay, the last thing here, we are at the process space on the system, and we see psaux, how much CPU time a process has occupied since its start. If you call psaux, for instance, you see, let's scroll up a little bit, or let's scroll up until we see the header of the table. You see how many, or yeah, which part of the CPU resources and the memory resources is used currently at this time from a process. And if I scroll down, yeah, I see there are some processes, yeah, using a part of the RAM from the system, yeah, but nothing really uses CPU. Let's try to run a command that uses CPU. Let's do something like this, cat dev 0, and let's redirect the output to dev null. Yeah. What does this command do? It just prints out everything that comes out from the special device file dev0. The special device file dev0 just gives out zeros, byte zeros, yeah, not ASCII zeros, but byte zeros. And then we just redirect this data stream, this never-ending stream of zeros. We redirect this stream to another special device file, dev null, and this special device file, dev null, takes all the data it gets and then just forgets about it. Yeah. So if you need a way to move your data away, no matter where it is stored, then you don't need this data anymore. Yeah. Just redirect this data to dev null. Not copy to dev null, but stream data, a data stream. Yeah, you can use the output of a command and redirect it to this file. I do this, and now I have a cat command running, a process running that wants to do every time something. Yeah, so now let's have a look into the output of psaux, and let's see if we see the cat process. Yeah, here's the cat process running. And you see the cat process has occupied the CPU for 15 seconds till now. Yeah? And it uses 102% of the CPU. Yeah? You see that this is a process that wants to run, and it uses a lot of CPU performance, yeah, at the time ps command was started. Yeah, this is only a snapshot from the current time we have here. If you want to see this more dynamically in action, then use a different command here, the command top. The command top is a command, and it is a task manager for a terminal. Yeah, but if you call top only without any additional parameter here, then top gives you a list or a partial list of all running processes on a system sorted by its CPU usage or by their CPU usage. Yeah. You see that the cat process here uses the most CPU resources currently. Yeah. It uses 99.7% or 100% of a CPU. Yeah. And all the other processes, I don't know. Let's have a look at this line. We talk about the CPU. Yeah, and this line here shows you that all my CPUs, you see there's an S here, CPUs, all my CPUs are running and are to 49% idle. For 90 or 49% they do nothing. Hey? What does this mean? Yeah, simply we have multiple CPUs on the system. We have multiple CPUs on the system, and if I am within the top command, I can just hit the 1, the key with the number 1. Yeah, and just hit 1 now, and now I see I have 2 lines for the CPU statistics, 1 line for every CPU on the system. And now I see one of these CPUs isn't idle. It doesn't have any spare time. The other CPU, the second CPU, is idle here. Yeah. So you see that a cat process uses or occupies 100% of one CPU, and this first CPU is. Now in this example, the other CPU has plenty resources left. Yeah. If we want to, we could start a second cat process to occupy both CPUs. Let's terminate this cat process by hitting Ctrl+C. Let's start again a cat process, this time in the background with the added ampersand at the command line, and let's start two. Let's start two of these processes, and now let's see with an output of top we have 2 cat processes running. Yeah, these time columns here, these time fields go up nearly in real time, yeah, because the cat processes every time wants to do something. And now you see the CPUs here don't have any spare time. Yeah, they are for 0% idle. Yeah. Okay, so the ps command gives you the information what is currently running. The ps command gives you the information when was the command started, how many CPU time was occupied by the command, and gives you the user process is running as. And if you want to see it more dynamically, yeah, which process occupies or is responsible for which load on the system, then just use top. Yeah? By default, you see if you call top, you see the CPU usage as the main sorting element here. Yeah? If you want to, you can sort your processes by memory, for instance, by hitting uppercase M. Yeah? But for now, let's stick with this. Yeah, 2 cat processes running for 100%. They are using nearly the 2 CPUs here, and you see that the load average is going up until it will reach the 2. Yeah, the load average is information that says how many CPUs wanted to run in the CPU queue. Yeah? We have a process scheduler on the system, and the process scheduler takes a process from the queue that wants to run, yeah, and feeds this process to a CPU for some time. Yeah? And then it goes back to the queue and takes the next process. And it remembers how many processes were on the queue for running, yeah, and then he builds up an average. He builds up an average for 1 minute, an average for 5 minutes, and an average for 15 minutes. And this is the load you see here. Yeah, this is the 1 minute average. Within the last minute, there were nearly 2 processes on a system that wanted to run. Yeah. Okay, so you see that the system now for a minute or so is completely loaded. I will see. Yeah? Not overloaded, but it is completely loaded by memory, the system, for the last minute. Not for the last 5 minutes and not for the last 15 minutes. So you see here that you have a spike. You have a spike in the CPU load here. Yeah. So the 15-minute load average, yeah, hasn't reached the number of CPUs, and this is important. Yeah, the number of CPUs tells you how many processes can run in parallel, and if there are an average more processes than you can handle in the process queue that want to run, yeah, then your system is overloaded. If the number is lower than the number of processes you can handle, then your system has spare CPU resources. Yeah, let's have a look. Let's start a cat process more than 2 times. Yeah, now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have now 10 cat processes. That means within the next minute or so, the 1 minute load average will go up to 10. Yeah, and now we see that our system is, if we only have a look at the last minute, it is overloaded. If we have a look on the last 15 minutes, yeah, the system had resources left. Yeah, so take this into account. How many CPUs do you have? Yeah, and then compare the number of CPUs you have with the number of processes that wants to run. Yeah, to say if your system has free resources, if your system is loaded, or if your system is overloaded. Yeah, and overloaded means that the cat processes here now don't run. Won't run in real time. Yeah, they have to wait until another process in the queue was fed to the CPU, and then they will get a CPU for its own. Yeah. Okay. So this is all about the PS command. Yeah. Again, PS AUX, PS tree. We have the top command here, and we have talked about the load average. And the load average is, or can be, really fast seen if you call the W command. Yeah, this is the first command I start every time I've just logged into a system. I just start a W command, then I see the uptime, the really huge uptime here, and I see what's the system currently doing. Yeah, what's the system currently doing? And we have a load here. So I see at a glance, at first glance, that the system is currently overloaded. Yeah, if I kill all these processes, kill all cat, if I kill all these processes, then we will see the top command gives you nothing more to do, no more cat processes. The CPUs are nearly 100% idle, and we will see that the load average now drops way below this one mark. Yeah. Okay, so this all about the PS tool, the process visualization we have here. Yeah, I think I will do in the next weeks something about the process management at all. Yeah. What about a kill and so on, the signals you can send to processes. Yeah, okay, if you want to know more about such tools like the ones we talk about here, yeah, have a look at the Shell Toolbox. Shell Toolbox is an ebook you can buy for really small amount of money. And this is a book I have written mostly for my students and clients to give them a reference for all the tools they can use, for all the tools they need. And now you can have access to this tool too, and to this book too. If you are interested, yeah, have a look at shelltoolbox.com. And if you have any questions, if you have comments, yeah, leave the comments in the comments. Okay, so see you next time. This was Robert Wolfart. It was me a pleasure to have you here. Till next time.